Welcome everyone. Today we are going to be doing something interesting. So look at the name of my channel, That Nerd Who Swims. Now look at the first two letters, That Nerd. Yes, I am that nerd. And being that nerd who swims means I'm going to be doing a very nerdy thing called a math competition from high school, namely the 2024 AMC 12A. So this test basically you have you have 25 questions, you have 75 minutes, and then it's a couple logistics. Yeah, you try to solve as many as you can. And our goal and today's goal is we have three levels of ambition. The first ambition is Amy, which should be not too bad probably, but maybe I might end up being stupid and silly a couple. The next level of ambition would be to be my younger sister, who I helped to qualify for this. And the third level of ambition, well, that's the second level. The third level would be to try to get at least 100 or triple digits because that feels kind of special when you go below triple digits to above triple digits. And then the last level of ambition would be to beat the prodigy in our region who scored a 111 on this test. Yeah, that is really high if you don't know. So, anyways, I got my timer here. I got myself here. We're going to be starting soon. And here we go. Three, two, one. Test starts. Okay. What is the value of 9901 times 101 minus 99 times bruh? Okay, what the are you doing? So this would be 9901 times 101 minus, yeah, I'm going to be verbally talking about it, minus 99 times 101 times 1. So 101, so okay, why are we doing this kind of wonky problem, bro? So it's 9900 plus 1 times 101 minus 99 times 10100 plus 1. You know this has to end in 2. That's one thing you could probably deduce. Never mind. Another way you could probably deduce from here is 9900. 9901 times 100 would be 99000 990100. And you have to add 9901, so then 100000. You have 10000001. Yeah. And then 99 times 10101. Yeah, why are we doing such complex math here? Be 1010100 minus 1101 minus, it'd be 9 on the top. Yeah. Yeah. So I think that would be it'd be 1,000,001 minus 999,999. So I think the answer is 2, which would be A. Model will use to estimate the time it will take to hike to the top or bottom is T equals AL plus VG, where A and V are constants, T is time minutes, yada yada yada. Model estimates it will take 69 minutes if it's 1.5 and 800 feet, as well as if a trail is 1.2 miles long and ascends 100 feet, 1100 feet. So if it's 4.2 miles and ascends 400 feet. So I think the strategy would be you have to find A and B and then plug it in. So 69 minutes, it'll have to be L times A, which is 1.5A plus 800B. And this is also going to be equal to 1.2A plus 1100B. Now you have to find A and B based off of that. And then you say point 3A is equal to 300B, and you get A is equal to, so I'm thinking A is 1,000, and then 100, 1131. Well, so 1.2A plus 1100B is equal to 1.5A plus 800B. So that means 0.3A is equal to 300B. So A is equal to 1000B. So if A is equal to 1000B, then that means 2300B must equal 69. And that'd be 3. So B is equal to 0.03. And then that means A is equal to, so we have 45 up there, and then 32. Wait, am I trolling or am I not? We cooked or cooking, yeah. 36, yeah. So 3645, and then that means A should be equal to 30, B is equal to 0.03. So if it's 44.2 miles long and then since 400 feet, then that means it's 126 plus 0.03, 400. Wait, am I? So if it's 4.2 miles long, thousand times B is 0.03, that means 26, and then you send 400 feet, well, that's 4,000 goes down 40 plus 120 is 246. The answer is B. Wow, these first two problems have been kind of tough, I'll say. Number 2024 is sum of two not necessarily distinct two-digit numbers. Least number of two-digit numbers needed to write this sum. My idea is, can't you just add up a bunch of 99s? My initial idea would be to add a bunch of 99s. So then going about a quote-unquote greedy strategy, so then you take 25. But there's probably a better way you could do this. Yeah, my idea is greedy strategy, but I don't think greedy strategy is the best way to go about this. So, or maybe it is, never mind. So my idea is you just have 99 20 times. So you get 1980, and then you add 44. So then you take 21 times. But I'm wondering if it's possible to do this in 20. Wait. No, I don't think it's possible to do it in 20 times. Because otherwise, then you'd have to have at least a number that's greater than 100, and that's not possible. So I think the answer is B. Least value of n such that n factorial is a multiple of 2024. So 2020. So I think this just comes down to prime factorization. You have 46 by 44, and then so you have to have, it has to be divisible by 46 by 44. And the first number I can think of is 23. I need to make sure that this actually works. Well, I have 11.4. I have 23.2. The answer is D. Data set contains 20 numbers, some of which are 6, have mean 45 when all the 6s are removed. So how many 6s are in the original data set? So that means if it has, the total has to be 900. And then you have 6 times x plus So that means 900 over x. Wait, okay. So the main data set will have mean 66. You have original sum of 900. That means if you remove all the six, you have to be a multiple of 66. So I'm thinking 660, 726, 792, and then 858. So that means you could have either 18 sixes or 7 sixes. But I feel like 7 makes more sense. So let's say we have 7 sixes. And then the other 13 by 66. I mean, that'd be 858, yeah. But then it's like if we have 18 sixes, if we instead have 18 sixes, then that means we'd have to have two numbers that average 66, but that doesn't quite stack up. Yeah, so the answer here would be 7, I think. So the answer is D. Because if the answer was because if it so I realized it had to be 18.7. Well, one 18 is not here, and second, the other that means the other two numbers have to average 66. But if we add 108 and 132, we get 240, which doesn't quite work. However, if we do 7 times 6 plus 13 by 66, I think this should work. Yeah. So the answer is is D. Now the product of three integers is 60 and what's the least possible sum. I think the three integers, well, you have 3, 4, 5. Intuitively, I can think of 3, 4, 5, so I know the answer probably has to be smaller than that. Since I got 12 and it's not there, so it's probably smaller, and because they're asking for at least possible sum. Yes, I know. Yes, maybe my talking is a little annoying, but yeah, I don't care. I'm sorry. Like, there's 652. I think we can go a little smaller, right? Do you think so? Positive sum of the three and oh shoot, I'm stupid. You can also do negative. You can also do negative. Go negative. So that means you can have two negatives and a positive. So that means you could go 3, 4, 5. Well, you can do well, choose two of them to be negative and one of them to be positive. 3, 2, 10, negative 3, negative 2, then now you get to 5. I want to see if I can go even smaller than this. If I can go smaller. Yes, I know I suck at imitating British accents, but 652. Well, three. Well, you have to get two numbers that are rather small. You have to get two numbers that are relatively small compared to one kind of big number, I guess. Well, 1, 6, 10 also. Shoot, I'm stumped. I forgot that one could be a possibility. Yeah. What is this guy doing? But I feel like the answer would be -1, -6, and 10 to get me an answer of 3 because that's like the smallest. Unless you can find a number such that a, b, and then a plus b plus two ab times a plus b plus 2 equals 60. Anyone? Ta-da! Yeah, I think the answer here would be 3. Yay, I love Geo. I totally don't hate Geo. So ABC is 90, VA equals BC, which is root 2. Nice, thank you. 45, 45, 90. And then P1, they all are on the hypotenuse. So then over here, the idea is that like you basically equal this, you split up this. Well, okay, yeah. You split this thing up equidistantly, point 0.1, point 0.2, 2024, and into 2025 points. So in the length of each of these is, the length of each of these is 2025. So this is a very interesting problem, I must say. So one thing I can think about is, well, you're going down. So you're doing root 2 times 2024. And then you're adding, so each time you're doing, so you're going, this is y. Y direction is root 2 times 2024. And then in the x direction, well, you can do 2, well, it's root 2 over 2025 I hat minus root 2 over 2025 j hat. It's 1 times that, and then 2 times that, all the way to 2024 times that. So, well, maybe this is not exactly the most ideal way, but another way I could think about this is, well, they all have to be symmetrical. There's 10, 12 of them, and they're all going to go 45 degrees to the x-axis. So that means, you can go each of the sum of two of them at a time will be equal to root to 2, because if I have a square, well, okay, I don't know how to explain this, but you go out 1 and then go out 2. So that means if I add, so I have the midline and then I do one top and bottom, and if I add them, I have a vector of length 2, and then I just sum all of them up 1012 times to get me the value 2024. So I think the answer would be D for number 7. Number 8, how many angles with that? Yay! Okay, great. Satisfied. Log of sine 3. Yeah, yeah. Yeah, why does this actually feel kind of hard? Low key. Log sine cosine theta equals 0, then that means sine 3 theta cosine 2 theta has to equal 1. So that means I think the idea here is you have to find a theta such that they're both equal to 1. Because if any of these are less than 1, then you have 0 times, well, then you have log of 0 times log of something less than 1. Since you know sine and cosine can never be greater than 1, either they both have to be 1 or they both have to be negative 1. Here, that's what I'm thinking. So for sine to be 1, well, that's pi over 2. For cosine to be 1, and that's 0. Yeah. So for sine, so that means, yeah, sine 3 theta cosine 2 theta has to equal 1. And that means theta has to can well, in this case that means theta can equal 0 pi over 6. No, not 0, pi over 6, and then that plus 2 pi over 3, which is 5 pi over 6, and then 9 pi over 6. And then for cosine 2 theta to be 0, for both of these to be 1, and then I can make another column of -1, cos theta can be equal to 0, 0, and pi. Yeah, there's probably no overlap. And for -1, well, you can have pi over 3, pi, and then 5 pi over 3. And then likewise, cosine would be pi over 2, 3 pi over 2. But there's no overlap. So I'm thinking as a result that must that mean the answer would be 0 because yeah, there simply just isn't overlap. Or maybe I might be trolling. Who knows? We'll see by the end. Let m be the greatest integer such that both n plus 1213 and n plus 3773 are perfect squares. So that means, so my idea here is you have to find two numbers that are 2560 apart. Yeah, they have to be 2560 apart, which means which means because it's even, so I think you should have x and x plus 2. So that means x plus 1279 must be x plus 1 squared. So that means x is equal. So that means x is equal to 650. No, not 650. 640. 639. So 639, 640, and 641. That's what I'm thinking. And then yeah. So it's 639 squared, and then that minus 1213. So that's 1 minus 3. That's going to be a units digit of 8. Answer is E. Finally, something with E. Yay. Okay, so surprisingly, the first couple problems have been easier than the first couple problems have been relatively chill, I will say. What is B? A is radian measure of smallest angle, and then smallest angle in the 724. So A will be 5, 7, 24, 25. I feel like B would be equal to A over 2, but sine 2A is equal to 2 sine A cosine A. Well, 2 sine A cosine A. I think 90 minus B is equal to 2A. So that means 90 minus 2A is equal to B. So does that mean the answer is just C? I'm kind of guessing over here because, yeah, I'm kind of guessing over here. And I've already taken up a good amount of time. So that means, well, cosine of B, well, cosine B is equal to 24 over 25. And, sine A is equal to, well, 2 sine A is equal to 24 over 25, but 2 sine of 90 minus A is also equal to that. So, but you don't want 90 minus A. So cosine A is equal to 4 over 5, which means, yeah, I might just skip over. So let's go to 11. I know typically the test starts getting a little tough around here. There are k integers, positive integers, b so with b in that range such that the base b integer divisible by 16. What is sum of the digits of chi? Such that this is divisible by 16. Sum of the digits. Okay. 2024 base. So that means 4 plus 2b plus 2b cubed must be divisible by 16. And that means, well, I guess the meaning of this would be, so 2b cubed mod 16, it'd go 1, 8. Well, no, no. Well, if b is positive, then if b is even, so let's say b is even. Well, 2b cubed is going to be a multiple of 16. So if b is even, then that means b has to be equal to 7, 14 mod. No, b has to be equal to 6 mod 16. Yeah. Yeah, b has to be equal to 6 mod 16. So that means it's 16, 22, 38, etc. up. 2024. 40. 1, 44, 2. 4. 26. 2016. Six. I think the answer would be like 127 even numbers. And if it's odd, well, 1 gets you 1357. Well, 135, let's look at 135s. It's 6 and 14 mod. I guess 14 could also mod 16. 6 and 14 mod 16. Yeah, why is this such a bashy problem? Yeah, I'm gonna go to 12. The first three terms of a geo sequence are A, 720, and B. Sum the least possible value of B, digits of the smallest possible value. Well, you want them to be close, isn't it? 90 and 80. Yeah, because they're integer. Oh, 720 squared. Never mind. Yeah, so that means you can have 720 to 720, or you could like try to shrink one of them a little bit. Yeah. 720 is, well, we know this is 6 factorial, so that's 655. You can go to 750. No, no, no. Don't want to go to 784. 5/6, not exactly. Go 9/10. You can make it 800. You can make the 800 probably. I'm thinking that would also be a little big, I guess. So that means you could probably go smaller. 784 probably wouldn't be a good choice either. So that means, well, you could do 15/16, I guess. So wouldn't that be 744? But no, 768. I mean, so wouldn't that be possible, or is the answer even smaller? I'm wondering. Yeah, I'm thinking the answer would be over here. So let's look at number 10. What's the radian measure of the smallest angle? In 345, what's the radian measure of the smallest angle in 724/25? Sine 90 minus b equals sine of 2a. So that means 90 minus b is equal to 2a, or 90 minus 2a. B, so why we can't just do 180 minus 2a? Well, because I guess in that case, this would be negative. So we're just gonna stick with pi over 2 minus 2a. And then 7, from 11, there are exactly k positive integers with 5 in between the between that. Yeah, 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 we know. So I guess 6 mod 8. I guess if you're equal to 6 mod 8, then that would work. Okay, now things look a lot better, which means there are 250. Yeah, 252. Wait, is it 253? 253 possible ways such that for even numbers. And then for odd numbers, we'll look at 1357. 1 gets you, well, 1 actually gets you 8. 3 gets you 6. 64. Okay, 3 is a good number. 5 gets you 5 is not good. And then 7, well, 66, 700, 704, which works. So 307 works. So it'd be 257 plus 506, isn't that 759? Shouldn't that also be 21? Yeah. So I'm thinking 21, 21. Okay, now we're at number 13. A graph of this thing has an axis of symmetry. What's a reflection of point -1 over, comma, half over this axis? So where this is symmetric, so the idea is that like if it's e to the negative x is just equal to e to the x flipped over the y-axis, which means, well, if you do e to the x plus 1, that means I shifted left 1, and then and that means you're equal e to the x plus 1 is equal to 1 at -1, and e to negative x is what, 0. So that means it's probably symmetric at x equals -0.5, and that means -1 comma half. You probably, so then you have -1 comma half reflected over x equals -0.5, and then you get 0 comma half, and then you get an answer of D. Numbers in order of each row and the numbers of each column in order of each column of a 5 by 5 array form an arithmetic progression of length 5. The number in positions 5, 5, 2, 4 are 0. What number is in position 1, comma 2? Yeah, I don't really like that. We're going to go to 15. The roots of x cubed plus 2x squared minus x plus 3 are PQR. What's the value of that? So square r squared plus 16 times square plus q squared plus r squared plus 64. Well, 60, and then that's p squared q squared plus or r squared plus q squared r squared plus q squared plus r squared plus 256. Okay. Well, one of them is 9. And then, yeah, this is just a bunch of bunch of bashing. P plus q plus r squared minus 2 times -1. So p squared plus q squared plus r squared is equal to p plus q plus r squared minus 2 times pq plus pr plus qr. And it'd be to 4 minus 2 times -1, which is equal to 6. And then that, well, yeah. Be 1 minus, it'd be 1 minus whatever gooberish that is. Whatever gibberish that is. Minus 2pqr squared. 1 minus. So it'd be 1 minus 2pqr, p plus q plus r. 1 plus 6 times 2 is 13, so that would be 208. 217. Yeah, I don't know if this is exactly the way. I probably screwed something up. Arithmetic progressions are numbers are 0, 48, 16, 12. Respectively, what is in position 1, comma. Yeah, what is in that question mark? 12, 48. What would be up here? I mean, I guess I guess one thing you could do is you could just try to put a number there and then see, but I don't think that's exactly a great way to approach this. So you could do A, you could 2A, 3A, 4A, and then B, 2B, 3B, 4B, and then you could label the size A, 2A, 3A, 4A, and then B, 2B, 3B, 4B, and you could say 2B plus A. Wait, oh, but it just has to be air. Just has to be arithmetic progression. It doesn't have to necessarily be equal though. So say A plus K plus 4K. So then you can say 4B plus 12 over 2 is equal to A plus 4K. And then 2B plus 6 is equal to A plus 4K. Say A plus 16 is equal to 2A plus 2K. Yeah. 4, 10, 16, 22, 28. Then you can say 0, 16, 14, 96, 30, 18, 33, 48. Okay, I kind of got lucky. 12, 40. Yeah. It'd be 29. Yeah, so I kind of got lucky on this. This is just kind of like a puzzle. You just solve until you find something that works. One thing that kind of helped me was just I just thought, just try to think of a nice sequence. And yeah, yeah. So we got through 14. Technically, if I got all of this, I would hit my goal, but I'd have to actually get things right. The roots of that are PQR. Wait, why is problem 17 the same as problem 12? Did the test makers screw up or what? Like, someone give me an explanation for this. So roots of that are PQR. Like, what kind of test makers are these people? I mean, a nice way to go about this would be just, I wish I had the solution for problem five, but that's not how things work. So I kind of have to resort to this thing called Vietta's formula. And I feel like this might be very unclean, I'll say. This feels like a very bash kind of problem. Unless someone can tell me how to not make it a very bashy, like there probably has to be something that looks cleaner than just brute force bashing, but yeah. Yeah, I remember one time there was like this bash, wow. It was like everyone was yelling bash, wow. Yeah. Uh, I don't see any rational roots possible, but could there be something imaginary? Can an imaginary solution be possible? Yeah, it's probably going to have to be imaginary. So maybe I should just go about the brute force, or should I attempt problem 16, which feels much more fun? So 12 tokens, 3 red, 2 white, 1 blue, and 6 black is distributed at random to 3 game players, 4 tokens a player. Probability that some gets red, some gets white, and remainder gets blue. Gets all one. Oh, one person has to get all the red. One person has to get red. This B, and then someone gets white. So you have to have one person with all the red, someone with white, and then someone with blue. This would be a little tough, but I feel like I want to attempt this problem mainly just for one, for quant purposes, and two, because I like probability. So I feel like one way you could go at this would be, I mean, if you have all the red, then that means you can have one black, two blacks, and then three blacks. I feel like, okay, so one thing I could try to do is figure out how to split the blacks. Probability of A given over B given B. I think it's so probability of A over and B over probability of B. So let's just say, so what's the probability that I split it 3, 2, 1? So with black token. Well, I know I can't have 5 belonging to someone. So I can go 411 330. I can go 420 411 330 321 and then 222. Yeah, these are the ways I think I can we can split it up. And then we have to find the probability that we split it up in that many. Choose three, so that means there's 56, but we can't do 510 and we can't do 510 and we can't do 600. So that eliminates nine possibilities. So that's 47, 6, 1, 6, 1, 3, 3, 6. 28. Actually, yeah, never mind. There's 19 ways. Yeah, there's 19, and then so we have 6 out of 19 that we actually split it properly. So now we split it properly. What is the chance that we get RRR WW blue? Chance that we get RRR WW blue would be so the chance that gets it would be 1/6. Oh, and then by 3/5. And then out of the five, I can choose two. Yeah, so I have 1/6 chance of that person who got three blacks to get the blue. He has a 1/6 chance, and then the chance that and then if I know he has a blue, then the chance of this getting both of the blacks is 1/10. And will him getting three and then three and then 361. Yeah, it'd be a sixth by a tenth, and then I shouldn't be 191, but maybe. But that seems a little too. That's not even a possible answer, bro. Okay, yeah, yeah. So one thing I'm thinking, the chance of you, and then you could multiply by, but is that the way? Is that the way? I don't think so. I think I'm just trolling. Yeah. So blue can get a sixth, and then white. If I know that is true. So my idea is that like the probability of A given B is equal to the probability of A and B times probability of B, but 196 over 4. So I'm thinking what you could do is you could split, see if I can split 321. Like how do I split 321? There's 6 over 19 ways, right? So there's 6 choose 2, which is, I mean 8 choose 2, which is equal to 28. But I can't do 510 and I can't do 600. So that takes out 9 choices, which gets me 19. So there's 19 choices, and then there's 6 ways I can get a 321. So now let's say I have the 321. 321. I was thinking it'd be 1/60th that we satisfy that one player gets red, all the red, another gets all the white, and then another gets the blue. But player one. So let's just think about player one, two, three. Like one has 3 slots open, two has 2 slots open, three has 1 slot open. How many possible ways can I do this? Wouldn't it be 720 over 6 times 2? Wouldn't it be 120 possible ways? Because they're indistinguishable. I mean, if I do that, that's still 381 and not. That's 381, and it's not going to get me the answer that I want. Half 2 feet 1/4. Well, it's equal no matter how you do it, how you arrange it. So it's just 6/19. The chance of you getting the black, how you distribute the blacks is 6/19. But now it's like we know that the blacks are distributed like that. How do we figure out how to distribute the others, the red, white, blue? Now that we already have that information, so now we have 3 boxes, and then 2 boxes, and then 1 box. Yeah. Now this is, yeah, I don't think I'd be able to get here. 35, 3, 20. More minus 7, 7. minus 18 plus. X. 18 minus. Here's 21. I'm probably not going to 19. Screw that. But the chance is 6 over 19 that one person gets the red. So now we have to have ball. I think we can reduce this to balls and bins, but this is not doesn't exactly go very nice. So I'm thinking you could do RRRWWB. 3, 4, 5, 6. Say 6 by 2, and then that's 1 over 60. But then I get 1 over 190, which is not exactly how what it should be, I'll say. So maybe my conditional probability of A, well, probability of A given B is equal to probability of A and B over the probability of B. Wait, is it B? Yeah. That being true and this being true. So that's the thing. Then what is m plus n? What would m plus n be if? probability that player A gets E half times the probability of half by 2/5 by 1/4. So then you have 1 in a 20th chance of getting that. And then the probability of this working is 2/3, half 1/60. But then but that just gets me the same old thing again. So 1/6. Not just 1/60th. The chance of you distributing it like that is 1/60. One oh 20 120 330 321, and then it's 321, and then 222. So you have 136636, and then 3 10 666. That's 28 total. Or I could just figure out all the ways you can. No, I get it. And then the order in which I do this will be. Well, there's 60 ways. Okay. Shoot. Yeah. Maybe I've gone a little. Maybe I'm just, you know what? I'm just gonna solve 15 and probably call it a day. Square q squared r squared. PQR is equal to -3, so that's 9 plus 64. Yeah. 16 p squared plus q squared plus r squared. The sum is -2, so that's 16 times 2 squared minus 2 times sum of that, which is 1. So you add 32, and you plus add 64 times q squared, and then yada yada yada. 6105. 64 q plus r squared. That's 4 minus 2 times pq plus q. Negative 1. Oh, that's 6. So that's plus 96. 169. Nine plus 64, which is 73. R squared plus r squared. PR plus QR. That squared minus 1 minus 2 squared. And then that's when I can. R is negative 3, so I get 9 and 64. 73 plus 16. So I know it has to be 6 multiple 64. Oh no, never mind. It's 4. Shoot. Four and then 16. 4, 5. I think it'd be 75. And the answer would probably be 75. I think it's 75 because the thing is you have 9 plus 64 plus, well, you have 4 times the sum squared, which is 4 minus 2 times the sum, which is negative 2. Wait, but wouldn't that be 8? P plus Q plus R squared minus 2PQ minus 2PR. Well, PQ plus PR plus QR is going to be equal to negative 1, which is 4. Sum squared. Oh, so that'd be 4 minus 4, and then that's 0. So you get 75. And then, well, that has to be whatever shit that is an integer. So then you just end up with the number 75. Yeah. So time is basically running out, and I did not check my answers. So it's pretty likely I might have sillied something. I was able to get through problem 15 and kind of give a good try at 16. Problem 16, this is probably not exactly the best strategy to do. Maybe I can give 16 one last try, but you know. 4-2. Like, I know it has to be 4-2-0. Oh, it's probably because it's not equally likely. 1, 2, 3. 1, 2, 1. 2 by 4 by 3 by 4. 11, 10, 9. So I have that, and then I get more. Yeah, and that's time. So yeah, I really wanted to solve 16, but just wasn't gonna happen. And now I can check my answers. A, B, B, D, D, B, D, A, E, C. I screwed number 11 up. E, D, C, and I probably screwed 15 up. Yay. Yeah, what was with 12? I'm kind of confused. Some of the digits. Wait, what? What is with 17 and 12? Like, look at this. And then look at this. Yeah, I don't know what's with AMC, but overall we got 13. We got 9 blanks. Yeah, I don't know what's with 17. What is with AMC? What is with prompt 17? Yeah, well, I got a screwed up version of that problem, so I think I'm just gonna not count it. So it'd be a 91.5 if we don't count number 17. But if you do count number 17, then I guess you could say you ultimately got 93. And so 15 was, yeah, I probably could have, I felt like I probably could have, I definitely had the ability to do better, but things, just sometimes don't turn out the way you want them to. And yeah, just have to kind of deal with that. But overall, I mean, I had fun doing that. And that's what I feel like is the most important thing. Probably, yeah, I probably silly. There was likely one case. Wait, yeah, I probably included something less than 5, and that could be the reason why I got that problem wrong. So yeah, yeah, silly errors are always a bane of my existence. But overall, pretty solid test. I would say if I had a little more time, it'd be even more fun. But that's cool. I'm gonna say thanks everyone for watching my live stream. I got a little dead at the end, but that's kind of how things go. And I'll catch you up next time. Take care, y'all.